So hello, and let's start. My name is Andrei Glashenko, and I work at Haulmont, a Russian-British development house. And most of my career, I have been involved in various logistic algorithms, like the one moving 5,000 AddisonLee cars around London, or moving bailiffs around people's houses. And here with me is my colleague Konstantin Krivopustov, who is our CTO and who will help me in case you ask something I have no clue about. So Haulmont is a medium-sized development house with roughly 150 developers, and we specialize in Java enterprise software. We have products in enterprise content management area and taxi fleet management, and we also delivered a few bespoke solutions, mainly here in Britain. With a few exceptions, all our solutions are based on Cuba Platform, which is a high-level Java framework we developed since the company started in 2008. And this worked really well for us, so we decided to create a separate product based on it. And first we trialed it last year in Russia to collect initial feedback and to fix a few glitches which would be reported. And yeah, the feedback was really useful. So after playing a while and translating documentation, we released it in English in April, and actually here at Devox is the first time we are presenting it. So why did we decide to create our own framework in the first place? Because this might seem like an overkill for a small company when we started. Actually, all our solutions were kind of similar, though they were in different areas and they were of different scale. They all were enterprise applications with hundreds of tables, hundreds of different screens using typical components like tables, buttons, etc., with complex business logic, reports, security, and all this stuff. And from solution for bailiffs to solution for taxis and to solution for content management system, they were all the same. All these requirements were pretty much generic. And also, the life cycle of our projects is typically 10-20 years. And if not more, for instance, we were talking recently about replacing a 40-year-old system. And we needed our solutions to be supportable and to be able to evolve over this period, over the whole life cycle. Of course, we could choose the technology stack from scratch every time for every new project. But we thought that making these different technologies work together takes too much time and also has certain risks related to architecture choices. And as a result, we thought that we needed a company-wide framework, and we started looking for options. However, the popular frameworks like Gradles were too basic, or better say too low level. And on the other side, frameworks provided by vendors like Oracle, ADF, were too complex and too expensive for us. So we drafted our requirements for Konstantin and his team, and this was first full stack. So we wanted the framework to take care of everything from database up to the user interface. High level, meaning that we wanted developers to be using high-level components like data-aware visual components like tables, like integrated security reports, and so on, so that we don't waste time on doing low-level work every time. Then, obviously, we wanted it to be web-based for ease of deployment and access from anywhere. And we wanted it to be feature-rich in terms that we wanted it to cover all these generic requirements which I listed, which repeated from project to project. We wanted them to be available out of the box, well integrated with each other. And then we wanted it to be uniform, meaning that ideally we wanted to use just Java to create the whole application. No JavaScript, nothing, no HTML. That was ideal. And it should be open as well, because if something in the framework doesn't fit your project, you should be able to override it, or at least you should be able to use a different technology to implement certain part of your application. So, as a result, we are combining quite a few popular open source technologies, and I will list the main technology choices that we made and the reasons behind them. UI technology choice was probably the most challenging. So here on the screen are examples of two typical types of screens. One is a browser containing multiple entities, and another is obviously an editor showing one entity. This is just to give you a flavor of what we try to achieve with UI. So once again, we wanted it to be web, and we wanted to ideally to use same language and cohesive technologies for the whole application. And the latter was important for two reasons. First is that this gives us the ability to assign a whole business feature to the developer, and as a result, running projects is much easier. And it also removes fragmented responsibility when one guy works with the database, another guy works with the server-side logic, another guy works with UI, and then who's to blame if something goes wrong? In our practice, this also gives more satisfaction to developers as well, because they see the end result of their work. They knew that they implemented this whole feature from beginning to the end. And the second factor is that having all code in the same language and typically in the same project makes refactoring so much easier, and it provides great code transparency, so the application becomes more maintainable. We looked around, and Vaadin was the perfect match for all these requirements, so we used it. And because Vaadin provided pure server-side Java for application development, and if we extended browser side of Vaadin components, this was again Java via Google Web Toolkit. Vaadin has a great set of visual components, and it has a convenient Spring-like layouts model. And it provided some sort of natural security for us, because no application code is running in the browser. Everything is running on the server side. As another small bonus for us, the server-side UI code, thanks to the layouts model, was suitable to be shared with desktop client. And as a result, we implemented support for both desktop and web clients in the platform. We use desktop for certain customers who require faster keyboard-only input, like call center staff, for instance, will be a good example, or who require integration with specific things like telephony. So this added to the standard web interface quite well. In the end, the great community which Vardhan has, and which became even bigger over the last years, and the patch license made the choice very clear. However, there are a few things which we came across with Vardhan, and I will list them. First, in early days, back in 2008, 2009, we struggled a bit with performance in old browsers. The JavaScript calculations for complex layouts were pretty slow, and the overall performance was not brilliant. However, fortunately, without much efforts from our side, the quick progress of browsers, especially Chrome, made this issue go away completely. So we're quite happy with performance at the moment. Then one more thing is that though using Vaadin components is very easy, if you need to create something new, or if you need to extend a component, this might not be that easy, because you have to know Google Web Toolkit, and it's just complex development. But again, this was not that important in our case, because just a couple guys create components in the platform, and other developers just reuse them. Another thing was that Vaadin layouts, like I said, they are very similar to Swing, and you create layout, add components to it, then set attributes of these components, all in Java code. So as a result, you may need to write quite a lot of dump code just to create a very simple layout. And Vaadin recently introduced the declarative layout support to resolve this issue, and we actually did the same, but a few years before that. So our generic UI allows to describe screens declaratively in XML, and use data-aware components. Finally, you should consider server-side memory consumption. The components model is stored on the server side, so user sessions may eat up to several megabytes of data, depending on how complex your screens are, or how many screens are open, or which data is in them. And this may become an issue if you have a public-facing application with an uncontrolled amount of users, for example, some portal targeted at wide audience. But in our case, most of our users were in the intranet, and so again, this was not a problem, because even the amount of users is thousands. Yeah, we can always just add another server to the cluster, and that's it. That's not that expensive. So all in all, Vaadin is great. We're pretty happy with it at the moment. It has been a great choice. Okay, so the next big thing is the choice of ORM. With a few exceptions, I believe that ORM is kind of necessary evil for enterprise software. I know many guys don't like it and try to avoid it, but I think such is life. It brings too much savings. And when it comes to ORM, the default choice will probably be Hibernate. However, Hibernate has one flaw. When it loads an entity, it is always loading all attributes of this entity. It cannot load only a few of them. And in most applications, again, this will not be noticeable. However, when it comes to loading large object graphs, this becomes important, and then this can have serious impact on the database. For instance, let's take a look at this example. This is a screen from our taxi management application showing a table with jobs, and it has 23 columns. As for the underlying model, you see on the, will it be right, 88, the amount of attributes for each entity, so it's 88 attributes for job entity, then 29 for account entity, and so on. And on the left side, you see the amount of attributes required from each entity, and most of them are from the main entity, from job, and then one from each other. It is typically a code or a name. Of course, in theory, we could just denormalize these fields and place them all in the job entity, but this is still quite a typical example, and we'll use it as reference. So in total, you need 23 attributes, and if you write SQL manually to fill data for this table, you'll probably end up with 23 or maybe 29 columns, depending on whether you need IDs. However, if you give this task to Hibernate, it will load all attributes of all joined entities. And in the result, it will load 273 attributes instead of 23, which is 10 times more than we need, and which is a lot. So I don't know, maybe this is one of the reasons why DB admins try to avoid ORM. Another thing is that it is not only putting the extra load on middleware on the database server, it's also put an extra load on middleware, CPU, and memory consumption when it processes these massive JDBC datasets. So this turned out to be not an option for us. We looked around at other technologies available, and we chose OpenJPA, in particular thanks to its fetch plans functionality, which allows working with partial entities. We wrapped fetch plan into our own abstraction to simplify its use, which is called view, and which is defined declaratively. So when a developer needs to load data via ORM, he needs to provide two things. First, a JPQL query, and second, the view describing the object graph or the list of entities and their attributes which need to be loaded. The views are pretty straightforward. You can see an example on the screen, and this is a view for fee entity, and it has 3 local attributes, date, end date, and amount, and a couple of reference attributes, linked case, where we use a previously defined view, active case helper, and fee type, where the view is defined in line, and it just takes one attribute, fee class. So it's pretty straightforward. And this works quite efficient, and in our practice, most of the queries generated by ORM are as efficient as queries which you would write manually, again, with a few exceptions. Unfortunately, OpenJPA has been abandoned by IBM now, and development has almost stopped. So, for instance, there is still no support for JPA 2.1, and we cannot use conditional joins, we cannot use stored procedures via JPQL, which is obviously far from ideal. So, currently we are migrating to Eclipse Link, which is better supported, and we plan to release this in next quarter. And we hope that we will have longer, happier life with Eclipse Link because it is reference JPA implementation, it's because it's supported by Oracle. So this is where we are now. And as for container, again, initially we used the JBoss because we had previous experience with it, so we didn't try to reinvent anything. But then we realized that we don't really need any application server specific, and we migrated to Spring Framework. So as a result, Cuba applications can be deployed to any lightweight Java web server. For instance, we use Tomcat for most of our application, and it starts up really fast. We have no problems with it whatsoever. So, and we use the following parts of Spring. We use dependency injection, both for middleware and clients. We use remote and via HTTP for communication between clients and middleware. We use RESTful web services and low-level task schedulers. For application-level task schedulers, like, I don't know, send a report to my boss every Monday, we use a custom implementation with some UI and so on. Okay, so these are the key technology choices we made, and now I would like to say a few words about extensions, which is, again, one of the key mechanisms in the platform. We came across the need of extensions when we started developing our own off-the-shelf products. And in theory, off-the-shelf products offer a great way to share development costs between multiple customers, thus making development and implementation for each of them easier, simpler, and cheaper. However, standard business applications will very often not fit the way customer business works. And then, if it happens, the vendor typically has one of the following choices. So the easiest is just say no modifications, just use it as is. And sometimes you can get away with it for some simpler applications or in certain areas. But when it comes to core business, very few clients will want to change their business just to match your product. So this option is not very viable. Well, maybe unless you're IBM or SAP or Oracle, where you can dictate to your client what they need. As another extreme, you can create a branch for every new customer. Again, it's very easy to start, but very soon they need to update your branches with new features from the core product, and the need to support different branches becomes very, very expensive. And unless your customer base is really, really tiny, this is actually a road to nowhere. As a compromise, a typical approach would be leaving some integration points in your software so that end customers could create a plugin and override certain parts of functionality of your application. Again, this is good because this helps you to have the same core product base for all customers, but at the same time, it gives you only limited flexibility. You can override only certain parts which you thought of in advance. We wanted to go further. We wanted to get the best of both worlds for our software. We wanted to be able to override almost every part of it, and at the same time, we wanted to be able to keep customers on the latest versions of our products. So we created the extensions mechanism. And extension is actually a project based on your base product. In the same way as the base product is based on Cuba Platform. And in extension, using overriding and inheritance, you can modify the base product. First of all, you can obviously add new entities, new screens, and new business logic, and this is pretty straightforward. You just write new code. But then you can add attributes to product entities. To do so, you create a child class of the entity in your extension, and you add the required attributes to it. Then you tell the platform to use your derived class instead of the base product one everywhere, including the base product code, and that's it. Then you can modify screens, and you can modify again every part of the core product screen, but you don't have to, say, copy the layout, change it to what you need, and then live with it. You just write a small XML snippet describing the change, and we will see it a bit later. What it gives is that it's not only simpler, because you don't have to copy-paste a lot. Also, when, say, in the base product we update a screen, you don't necessarily have to do anything in your extension. If the modified part in your extension does not intersect with this change, you can just continue working. The new change in the product will just be applied to your extension, no problem. Then you can modify business logic, and again you just create a child class from the bean in the base product and override the required methods in it. Then you just register this class in Spring with the same name as of the base bean. And finally you can modify visual component styles. And it is important that none of the changes affect base product code. It remains completely unaffected. All the changes are only in your extension. So let's see how this works in practice. So imagine that we have a client for our taxi solution who asks to add a column to the drivers table. So what we do for this is we create a class xDriver extending the driver class of the base product, and we add this iPad device attribute to it. Then we create this small XML snippet which describes that we need to add a column to the table with ID table. So pretty straightforward. And that's it. So then after that we can see that in our extension the table will have one more column, iPad. And extensions worked really well for us. So we have probably 20-something clients having their own extensions. And for some of them, the size of the extensions is actually larger than the size of the core product. And at the same time, we are able to update them all and keep them all on the latest versions of the products, which is very useful for us because it saves a lot of effort trying to support multiple versions and so on. So yeah, that is used very actively. It should also be noted that you can extend multiple base projects in your application. So for instance, when you create a new application using Cuba, you choose additional functionality which you might need in your project. For instance, reports, charts, or full text search. Actually, these are all separate projects extending the base Cuba project, and your application and they are just added as base for your application. Again, this is very convenient because this helps to encapsulate code, and if you don't need certain features, their code will not be in your application at all. So how do we develop applications in Cuba? First, as I mentioned, you only need Java, XML, and a bit of JPQL. And the main development tool is the IDE, because we thought it makes very little sense trying to recreate another IntelliJ IDE or Eclipse. Instead, we implemented a couple of tools on top which complement to the IDE and add more automation and convenience to the process. First, we implemented plugin and for IntelliJ IDEA, just because we use it. And it added certain Cuba-specific intelligence, like navigation between screens layout and controllers, injections, hints based on the message packs or your data model, and so on. Then we added hot deploy support, and this proved to be a big time saver for us, because normally when you need to make a change, you want to check it, how it looks, how it works. So you have to do the full cycle. You make the change, compile, get distracted, talk to someone, deploy, drink coffee, restart, then see result. Then you see that something is still not ideal, make another change, repeat this, and so on. Hot deploy shortcuts this circle. And you just make your change, and it is either automatically hot deployed by Cuba, or you invoke a task to hot deploy it manually, and you see the result almost immediately. You just need to reopen a screen in the running application, or click the button and invoke in a method again, so which is very fast. Finally, before the public release, we implemented Studio, trying to reduce the learning curve for those new to Cuba, and also trying to eliminate the remaining routine work. And Studio is a complementary tool to the IDE, and it takes care of project files and build scripts. It generates database update scripts, maintains them, runs them, does it all, stores them. It provides screen scaffolding, and it provides a visual layout designer for more complex screens. It generates tabs for entity listeners and services, and it's even monitoring your code to detecting changes and deploying them to the running server on the fly. And the typical developer workflow is a mix between work done in Studio and the IDE. Studio doesn't have its own metadata, so it constantly monitors code, and the changes made in Studio are immediately available for external modifications in the IDE, and vice versa. All changes you made in the IDE are available for modifications in Studio. So typically, you would start a project in Studio and let it generate project files and build scripts, so you don't have to mess with Gradle. Then you describe the data model, and again, let the Studio take care of the database, generate the default screens for you. So then you can go to the IDE because it's more convenient, and you can implement business logic in it. You can implement screens logic, and then you have a choice again. You can, when it comes to more complex screens, you can either use the visual layout designer in Studio, or you can do this work directly in IDE in XML. And IDE gives very nice hints based on the XSD. So it's a matter of choice, really. In our experience, more junior guys like visual designer, more senior guys do it faster in XML. So yeah, and then this process is iterative. You do it constantly again. You return to the Studio, do something there, do something in the IDE. It's very convenient. And the next step, we are considering proposing platform as a service. And again, we want to take this complementary approach here as well. We want to give the developer a choice, as he can work on the local project copy using either the IDE or Studio, or he can work directly with the cloud copy using Studio via web browser, or he can combine both approaches depending on where he is, what he's doing. So that's about it, and just drafted this very simple diagram trying to show where we see platform compared to other frameworks. So compared to low-level frameworks like, again, Grails, it's providing much more functionality out of the box, and it's also higher-level development, so you deliver your solutions faster. And on the other hand, compared to heavier platforms by large vendors like, again, Oracle, it is less complex, and it is not that much tied to any vendor-specific technologies. And it's also, there are also some PS solutions which kind of play in the niche between these two, like, for instance, Mendix. And Mendix looks like a great tool to deliver simple applications really fast and with minimal development. And I guess this is why business users or analysts like it very much. It's very popular. It's a big name now. But at the same time, I don't think this will appeal to developers, and I don't think that it is there yet to be ready for complex applications because of the more rigid architecture and the lack of choice of development environment options. So standing on shoulders of these giants like Vaadin and Spring, I think that Cuba adds to these frameworks quite nicely, and it covers this little green area. And we believe that it will be useful for certain enterprise applications, and it can save some developer years, or maybe developer lives, solving these tasks. So yeah, that's it, really. And Let's see if there are any questions on this online thing. Why Bluemix or AVS? Not really sure what's that about. Sorry? Okay. So anyway, any questions? Yeah. We actually started the platform almost from the start of the company because we had previous experience in previous companies with these enterprise things, and we knew that this framework approach works in our case. So this was kind of key ideas when we started the company. We wanted to be efficient, and because we played in this enterprise area and we needed to compete with larger names, like in Russia there is like companies like Luxsoft, EPAM, who have like a few thousand developers. We needed to be efficient, and this was our key idea, to be efficient. So we started from framework really before we started doing applications. Yes. First of all, it was an internal tool, and we use it for all our projects. And then I think we released it to another company in 2013, and then we trialed it with a couple of companies. They delivered quite nice projects really fast, and then we thought that it could be used elsewhere, and we tried to propose this as a product. Yeah? The database scripts are generated automatically based on the data model. So when you define the data model, these are all simple POJOs annotated for JPA. So the studio generates the database scripts. It supplies the scripts to the database, and it tracks changes in your model. And if you edit an attribute, it will generate a new screen and so on. And the platform is DB agnostic, so it's using database via ORMs. So it comes supporting Oracle, Microsoft SQL Server, Postgre, and HyperSQL for prototyping out of the box. But then if you need others, again, they can be more or less painlessly added. Yeah? It tracks the scripts which have been previously updated. So it tracks the number of the latest scripts which has been applied to the database. So when you release an incremental update, yeah, so it just applies the new scripts after that one. So that's it. That's our own. Okay. Any more questions? Yeah? Actually, in a standard way, we have standard unit tests. And what do we use for UI testing? Yeah. We not particularly have any like flow layouts. So what's our typical practice? Yeah, is that we use a platform UI for internal users, for intranet users, and where the UI requirements are fairly standard, like all these buttons and stuff, and the screen sizes are fairly big. You're not doing your like day-to-day business operations on a mobile screen. Worst case, you'll get an iPad, which should be fine. But when it comes to public side of our applications, because many customers have their own customer portals and so on, yeah, we usually use a different technology like Spring MVC, and the platform in this case serves as a backend, managing the data and providing UI for more complex UI for admin users or for internal users. So, and I mean, if we choose using a different technology, then we can use Twitter Bootstrap or whatever we decide. No, that's not an extension. So, Constant, will you answer better? So these public-facing portals, which are part of the application, that's just a separate project, and we have a special module for it, which provides integration with the platform. So and just basic infrastructure like login, logout, and. Yeah. No. No, these are separate sessions. And it's typically different users. So it's typically like internal users are using the full UI provided by Vaadin and platform. And external users are using this more fancy UI. Yeah? Yeah, it's all available on the website. It's cuba-platform.com, and it has online samples, and you can also download it directly from there, and then it comes with a few example applications with code which you can download and play with. And it also has like some video tutorials, like quick start, and should be really easy to start. And it comes with full source code, of course. Okay, so there are no more questions. That's it then. Thank you very much. Yeah, we're here at the stand, so you can come over and we'll show you how you develop things and how they look like. Thank you.